Good morning one and all. Today I am discussing about Applied Geotechnical Engineering 18 CV62 for 6 semester student module 4 lecture series 2. So the determination of bearing capacity by Terzaghi's equation. Terzaghi has done a notable contribution to the field of geotechnical engineering, and he has done a lot of research on the soil mechanics and foundation engineering, and he put forward so many laws and equations, and because of that reason Terzaghi is called as father of soil mechanics. One among his notable contribution is determination of bearing capacity of the soil. In order to determine the bearing capacity of soil, he has done some assumptions. The assumptions are soil mass is homogeneous, soil mass is identical in all directions, and it is semi-infinite. Second is the Coulomb shear strength law is valid. So the footing is a strip footing, the base of footing is rough, the footing is shallow, the water table is at deeper depth, the failure is by general shear failure, the load is vertical and symmetrical, the ground surface is horizontal, the soil above the base of footing can be replaced by equivalent surcharge load, failure surface does not extend above the base of the footing, the soil fails by formation of 3 zones. So according to Terzaghi, so he has considered a footing width B at a depth df, and if at all if a failure takes place, he says that 3 zone formation take place: elastic zone, Rankine zone, and shear zone. So the wedge ABC is analyzed, and he has put forward an equation called bearing capacity equation. That equation is given by QF is equal to CNC plus gamma DF NQ plus half gamma BNR, where C is cohesion, NC, NQ, NR is depending on angle of internal friction of the soil, gamma is density of the soil, and DF is depth of foundation, B is the width of foundation, where NQ is equal to tan square, it is square, that is 45 plus 5 by 2 into e to the power of 5 into tan 5. To substitute angle of internal friction, you will get NQ. You can substitute NQ in the FO equation. NC is equal to NQ minus 1 tan 5. You will get NC. And NQ, if you substitute it in NQ minus 1 to 1.5 tan 5, you will get NR. So NC, NQ, NR, you will get it. Suppose if the angle of internal friction is 0, then your NC value is 5.7, NQ value is 1, and N gamma value is 0. So correction for local shear failure, as we already discussed, if phi is greater than 36 degree, general shear failure; if phi is less than 28 degree, local shear failure. If it is a local shear failure, for corrections to the observed C and phi value is to be done. The correction is C dash is equal to 2/3 of tan C, and phi dash is equal to tan inverse of 2/3 of tan phi dash. These phi dash and C dash values should be substituted in equation QF is equal to C dash NC plus gamma DF NQ plus half gamma B NR to get the ultimate bearing capacity. Next, factor of safety is given by equation QF by QC. QF is obtained for ultimate bearing capacity. QC is maximum load that we can apply on the footing. So Terzaghi has modified the equation based on the shape of the footing. According to him, for square footing, the equation is Q ultimate is equal to 1.3 CNC plus gamma DF NQ plus 0.4 gamma BNR. Continuous footing is CNC gamma DF NQ 0.5 gamma BNR. Circular footing 1.3 CNC gamma DF NQ 0.3 gamma BNR. For rectangular footing foundation 1 plus 0.3 B by L CNC gamma DF NQ half gamma BNR 1 minus 0.3 B by L, where B is width of the footing, L is length of the footing. Remaining terminologies are one and the same. Next is bearing capacity for different types of soil. So that is QF is equal to CNC gamma DF into half gamma BNR is the equation. If it is a cohesionless soil, C is equal to 0. If you substitute C is equal to 0, it will become QF is equal to gamma DF into half gamma BNR. That means the ultimate bearing capacity is directly proportional to depth of the foundation and width of the foundation. As the width of the foundation increases, ultimate bearing capacity increases, or depth of foundation increases, ultimate bearing capacity increases. Case 2, when a bearing capacity equation for saturated cohesive soil means your phi value will be 0. If you substitute phi value will be 0, then your NC, N2, N gamma respectively in reservoirs bearing capacity equation is 5.71 and 0. Upon substitution in the equation CNC gamma DF into half gamma BNR, your QF is 5.7 C plus gamma DF. That means to say in case of a clay soil, your ultimate bearing capacity is directly depending on depth of foundation and it is not dependent on the width of the foundation. Suppose if you want to increase the bearing capacity, if you just increase the size of the footing, so in case of clay soil, never ultimate bearing capacity increases. Instead of that, for a constant width, if you increase the depth, definitely the bearing capacity increases. Case 3, for a surface footing, if a footing is resting on the surface, df will become 0. Upon substitution of df will be 0 in case of cohesive soil, CNC half gamma b nr. So in case of cohesionless soil, phi is equal to 0, 5.7 C. That means in case of cohesive soil surface footing, the bearing capacity is directly proportional to B. In case of clay soil, case of sandy soil, it is directly proportional to B. In case of clay soil, if surface footing is there, it is depending purely on cohesion of the soil, not on any other parameter. Next, case 4. So if a QU for unconfined compressive strength is known, then C is equal to QU by 2 or QU is equal to C into 2. Next, Meyerhof bearing capacity equation. The bearing capacity of a foundation has been derived by Meyerhof, taking into account of the shear strength of the soil above the base level of the foundation. They assumed a failure mechanism similar to that of Terzaghi's but extended up to the ground level, and he has done some assumptions. The footing is continuous, whereas Terzaghi has assumed that footing is a strip footing, and Meyerhof assumed that it is a continuous footing. A failure surface is composed of straight line and logarithmic spiral. He said that is composed of 3 zones. The soil where JBC beneath the face of footing is an elastic state principle of superposition, that is QU. That is a principle of Q into I. Summation of I is valid. This is the diagrammatic representation of Meyerhof analysis. Logarithmic spiral, elastic zone, radial zone. Okay. The equation of Meyerhof is given by QF is equal to CNC SC DCIC gamma DF into SQ DQIQ half gamma BNR SR DR IR, whereas C is cohesion, NC, NQ, N gamma depending on angle of internal friction. DC is the depth factor, so SC is the shape factor, I is incline factor. Coming to the objective type multiple choice question, Carl Terzaghi was the first to present the comprehensive study for the evaluation of bearing capacity of the rough shallow foundation. Yes, it is true. Terzaghi developed a method of determining the bearing capacity for general shear failure. This is true. The Terzaghi's bearing capacity equation is QF is equal to CNC gamma DF into half gamma BNR. It is true. Phi is greater than 36 degrees is a general shear failure. It is true. Option is A. Phi is less than 28 degree local shear failure. Option is A. Phi is between 28 to 36. That interpolate. Option is A. Factor of safety is P of phi QC. Option is A. Terzaghi's bearing capacity on square footing. Option is A. Terzaghi's bearing capacity on circular footing. Option is A. Terzaghi's bearing capacity on continuous footing. That is CNC gamma DF into half gamma BNR is correct. Option is A, that is true. So these are all the list of references used to prepare this material. I take this opportunity to thank for the Department of Collegiate and Technical Education as well as students for giving an opportunity to deliver this lecture. Students kindly go through the LMS content, and if you have any doubt in this subject you can always feel free to ask. Thank you.